Section 4 is the last of our probability sections. After this, it switches gears in the chapter and we go to statistics. We'll be talking about surveys and other mathematical things that are involved in statistics. So for this section, conditional probability. We're going to find conditional probabilities and we're going to use tables and tree diagrams to determine probabilities. So this is another tool that you can add to your toolbox for solving probability problems. Tree diagrams and tables are very useful. You've seen a couple diagrams on your homework assignmts. That Venn diagram, that is useful for coming up with probabilities. You're going to see how tables and trees can also be useful. So, conditional probability is the probability that event B will occur given that event A occurs or has already occurred. It's weird language there, but we'll figure it out. A contingency table is a two-way frequency table that contains data from two different categories. You guys have seen and you've been working with contingency tables probably since you started school. So these should be nothing new. You'll see what we are talking about when we get there. The notation for conditional probability, which is, again, event B occurring given that event A occurs or has already occurred, is this. Probability of B given that A is how you would read that. Event B is going to occur given that event A has already occurred. That is the probability that you're trying to calculate. This table that you see here is a contingency table. It's a two-way frequency table. It's called a two-way frequency table because we have two different categories here. In this case, males and females in thousands. And down here, actually, this would be three ways on this side. So a two-year college, a four-year college, graduate schools. So what we've done is we've taken it like a survey, basically, of a bunch of people. And we've split them into just males and females. And then based on the way that they answered whatever question it was that we asked them, like, do you plan to go to a two-year college, four-year college, or grad school? Or maybe we asked them, did you go to a two-year college, a four-year college, or grad school? It's irrelevant. It's all divided out into the way that people answered these things. Now, because of this table, we can answer things like the probability that a person is a female given that they went to graduate school. Read it correctly, and that will help you solve this problem in terms of what you're looking at in the contingency table. So the table shows students by gender and type of school in 2005. You pick a student at random. So all these names, all these people are in a hat, or they're all in an auditorium and you throw a sock at them and the one that you hit in the head is the one that you pick at random, okay? That's probably a little ridiculous, but you select a student at random. What is the probability that the student you selected at random is a female, given that you knew that this person went to graduate school, or is in graduate school, or intends to go to graduate school? No. Everybody that you are talking about went to graduate school. So it's like you just kind of in the dark grab somebody and you are told then that that person went to graduate school. What is the probability that that person is a female? That's what you're trying to calculate. Okay? So we're given that this person went to graduate school. That means I come over to my contingency table and I'm looking strictly at graduate school. So how many people were females who went to graduate school? 1954. Divided by how many people went to graduate school? So then you'd add up those two numbers. 3,000 what? 3303? That's how you set that problem up. All right? You're given that the person went to graduate school, so that means I'm only looking at graduate schools. And now I'm only finding probabilities of people who went to graduate school. I want it to be a female who went to graduate school. That's how you do it. Then you divide that number out and you get a percentage. What do you get? 59.2%. Okay, what is the probability that the person that we randomly select is female? How do we do that? We need to find out, yes, it's all the females divided by all of the people. So how many females do we have? $9,933 females divided by how many people are there? $17,472. That gives me what percentage? .85%. Now that could be expressed as a decimal, 0.5685. It could be expressed as a percent, 56.85. It could be expressed as a fraction. You just reduce that fraction. So how do I set up this one? So the way you read that is the probability of this person that I randomly select being a being a 4-year student. Given that they're a male. The given that thing is what narrows down this problem. I'm told that it's a male, which means I'm strictly looking in the males column. Now I need a 4-year student. So how many 4-year students are there? No. I'm told that they're a male, which means basically, for all I care in this problem, the females don't exist at all. Okay? They're gone. So I have 4,324 4-year college people divided by all of the males, which is what? 7,539. And I wind up with 50 what? 0.35% or 0.5735. So like I said, the trick on these is remembering which one is which. The given that, you read this correctly, the probability of a 4-year student being selected, given that the person that you picked was a male. The person we picked was a male, so we pick this stuff here. We exclude the females from being considered at all. And then we just want a 4-year college person. That's our wins, divided by the total number of people in that column for the ways. That's how you do a contingency table. You need to know how to do this for sure. So how do I do this? Americans recycle increasing amounts through municipal waste collection. Table shows the collection data for 2007. What is the probability that sample of recycled waste is paper? What do we do? Why am I circling recycled? Yes, they basically have told me that the sample that I pick is recycled waste. Okay? So I went into the recycled waste bin, which means I'm looking at this column. Now what? Yeah, we want it to be paper, so you do wins over ways, which is going to be what? Over the total of that, if you add it all together, 79.4. And what does that give me? 56.92. And since this is multiple choice, I can round that to the nearest percent, which makes my answer D, 57%. Okay? So on a story problem, you got to read it and understand what it is that they're giving you, what it is that you're looking for. They're giving you that a sample of recycled waste. They told you it's recycled waste. That's what they gave you. So that's why we're looking just in this column. Then we want it to be paper. So we're looking at this divided by all of that added together. Another way to look at conditional probability, this is the book's way that you're about to see, is using the same ideas that we've developed in other sections. Basically, you're doing wins over ways. Just remember that. Anytime you're doing probability, it's wins over ways. The book's formula is this guy right here. If you forget what it is that I told you and you look in the book, you'll see that. What does it mean? It means the probability of me picking this guy, given that I was told this already happened, is equal to the probability of events A and B occurring together at the same time, divided by the probability of event A occurring. So how do I find the probability of A and B? We learned that last time in the last section. It is wins over ways, but you multiply them together. You find the probability of event A, and you multiply it times the probability of event B. So in this problem here, we've got to figure out what event A and what event B are so we can find those probabilities. This formula severely complicates this problem. We can probably come up with the answer to this problem extremely easily just doing wins over ways and circling the correct thing. Otherwise, we're using this formula and making life incredibly challenging. So, another example of how I try to make your life as easy as possible in Algebra 2. Here we go. A utility company asked 50 of its customers whether they pay their bills online or by mail. What is the probability that a customer pays the bill online given that the customer is male? Let's do this problem the way that we know how to do it. What do? It says we're told the customer is male, so we're looking strictly at males. Total males is 20. There are 12 of them. That's the answer. Why would you do it any other way? You reduce that 3/5. So there's your answer. It's easy, okay? Now, would you rather do this, or would you rather come up with the probability of event A, the probability of event B, and multiply them together, and then divide by the probability of event A occurring? Much rather do it this way. So it is possible to do this. I don't recommend it. I recommend doing this, all right? Now in the book, obviously you're not going to be able to circle your tables, but you can pretend that you're circling the tables, visualize the circle around it if you need to help you get through the problem. On a quiz or a test, yeah, no problem, circle it, all right? You can now do 8 through 17. Is that all or odd? Oh. I guess that's why I just wrote 8 through 17. Perfect.